Hi, I'm back again. I hope everybody is well. I was going to do a couple of questions from section 5.2, from the homework in section 5.2. I asked folks to do Skill Builder 2 and number 45. So let me start in. Let's see here for Skill Builder 2. It's hard to read these. So let's see. I was going to do number 58. The instructions say find the indicated confidence interval, assume a standard error comes from a bootstrap distribution that's approximately normal. So anyway, number 38, it says find a 90% confidence interval for the mean, mu, if the sample has n equals 30, x bar equals 23.1, s equals 5.7, and the standard error is 1.04. And again, I mentioned this in the 5.1 questions. It's not the case that we need all these numbers. So they're trying to encourage people to get used to that in a statistical situation there'll be a lot of numbers. You have to know which numbers are the ones that you need. In particular here, for 5.38, it says a 90% confidence interval. So we need to know what is the magic number for 90. When we were finding 95% confidence intervals in chapter 3 and later on in chapter 4, we used the number 2. Well, in this chapter, we're going to use numbers that are more precise than the 2. And I mentioned it before, 1.960 is 1.96. It's the number that we'll use instead of 2. 2 was good enough for that chapter. But if we're going to put down some number, we might as well put down the absolute right number. So for a 95% confidence interval, we'll use 1.960. Well, the book has the number for 90% and also for 99. And let me see if I can find the darn thing here on the previous page. Page 395. Whoops. Page 395. And it gives the number for 80%, 90%, 95, 98, and 99. Now, I'll only ask a person to know the three: 90, 95, and 99. So you should know those three: 90, 95, and 99. You want to have them, marked some place convenient, turn down the book page or something so you can find those three. 90% confidence interval, the number that we're going to use, the number that's called Z star, it says Z star over here, the number that we're going to use is 1.645. 1.645. Okay, so back to the question. Question says 90% confidence interval for a mean mu if the sample has n equals 30, x bar equals 23.1, s equals 5.7, and the standard error is se equals 1.04. So let's give it a whack. Okay, so a person remembers what the formula for confidence interval is. The formula is going to be here. It's x bar plus and minus z star, that's the 1.645 that I went to look on the other page, times the standard error. SE, standard error. Okay, now these confidence interval problems turn out to be remarkably straightforward. They threw a lot of numbers in there to confuse you, but there's nothing actually much to do there. So let's see, what is x bar against 23.1? 23.1 plus and minus, that's 1.645 times, and the standard error, darn it, I can't remember what the standard error is. 1.04. 1.04. I'll take out my calculator and see what 1.645 times 1.04 is. 1.645 times 1.04, 1.7108. So this is 23.1 plus and minus 1.7108. And that's the answer. Now you can add the 1.7108 to the 23.1 and subtract the 1.7108. I'm going to do that in just a second to get the interval, which a lot of times a person feels more comfortable with, but that's the answer. So confidence intervals, once you understand what the idea of a confidence interval is, that it is an interval in which we think there's a good chance, 90% chance, there's a good chance that the true number, the population parameter lies, then the rest of the formula is all remarkably easy. Okay, so let me try the adding and the subtracting. So 23.1 plus 1.71, whoops. 23.1 plus 1.7108 is 24.81. to 4.81. And what happens when you subtract? 23.1, take away 1.7108. I got 21.39. 21.39, rounding down there. Okay, so so that's the interval. That's the answer to the question, and you happen not to need those other parts. All right, let's try the next question, the last of the two questions, question 45. What does it say? So here it is. It says average age for ICU patients. ICU admissions data set includes a variable indicating the age of the patient. Then it says find and interpret a 95% confidence interval for the mean age of ICU patients. So the mu here is going to be, if you tested every ICU patient ever in the history of the world, so that would be mu, and they get a mean, they get in their sample an X bar of 57.55 and a standard error of 1.42. Okay, so again, we're looking for the we're looking for mu, but we're going to make do with X bar because that's all we have. So X bar plus and minus Z star times the standard error. And what are we looking at here for the 95% confidence interval? 95% confidence interval means that Z star is 1.960. In the previous chapter we used 1.960, awfully good for practical use. And anyway, what do I got here for the numbers? 57.55. 57.55 plus and minus 1.960, and they told me what the standard error is. It's 1.42 times 1.42. I'll punch that out. 1.960 times 1.42. 1.960 times 1.42 comes out to be 2.78. So this is 57.55 plus and minus 2.78, and that's the answer. The only hard part about confidence intervals, not the formula. This Z star, there's three numbers that I asked you to be familiar with. It's not the formula. The hard part about confidence intervals is what are you confident of? And the answer is we are 95% confident. We think there's a 95% chance that in our interval lies mu. Not X bar, this is X bar. We know X bar. What we don't know is mu. So we know the sample age, what we don't know is the population age. If we were to extend this study over hundreds of years, that's crazy, nonsense of course, hundreds of ICUs, and not happening. But if we were, this is the number we would get. That number we don't know, that's what we'd like to know. We're 95% sure that it falls in that interval. Okay, very good. So short one this time. So next up, I'll be posting a video on the material in chapter 6, and we'll see you then. Okay, bye bye.